All right, cool. So thanks everybody for joining. Good evening. Happy Thursday. Any alerting, monitoring kind of Datadog fans out there? You know?
I had to look into it for my last live, but it was bigger than what we needed.
Yeah. I was first introduced to this tool in about 2015 when I was dealing with a lot of scale issues. My day didn't start off with let's build a new feature. It's like kind of let's keep the company alive. And with 10 million daily actives, they can tend to beat up your servers. So the impetus behind this talk is to introduce you guys to alerting and monitoring such that you at least get familiar with the concepts. It's a pretty deep topic. Can you see my screen?
Yep.
So let's just get into it then. An introduction to monitoring and alerting with Datadog. We're going to talk briefly about observability, which is something that leads into monitoring, but you first have to observe things. Once you monitor things, you can alert on them or you can do an analysis of what you found. But before I even get into that, maybe you want to talk about why. Why would you do this? And how would you do this? Just so you understand the motivations and begin to approach the tooling. I will then further talk about onboarding with Datadog, what their agent is and does, and then give you examples of monitoring and alerting that I've set up. Cool? This agenda
Cool.
work
Awesome.
for everybody? And for
Sounds
those that are working with me on the NASDAQ project, we'll take this further. We'll likely be using Datadog to instrument and monitor our cloud native Kubernetes clusters running in Azure. So pay attention, NASDAQ folks. All right, next slide here. So in terms of where does monitoring fit into this world? That has more to do with predicting failures than anything else. You can't monitor for something you can't instrument, and you can't instrument for random uncertain things, because then you'll just make engineers kind of sad if they get a bunch of spammy, things to look at. Obviously, you want to test your software before it goes out the door. That's your best effort to verify for correctness. And there's this middle ground where you could simulate failures through testing efforts or monitoring efforts in an effort to understand the behavior of your system before your customers have a bad UX. On the bottom of this pyramid is observing things. What's going on in the infrastructure, in the either on-prem or cloud providers, and the services and servers you have up and running. You get curious about what are the things I can observe, and then okay, what are the things I can monitor for, because I'm interested in these observations. And you take that to ahead and say, what am I learning from this? What is this data and instrumentation telling me about the behavior of our servers? So why do this? Oops, something went wrong. Like, how many times have you heard about an AWS outage or, a famous brand having downtime? It's kind of embarrassing and damaging to their reputation if there is downtime. There's all kinds of sites you can look at, downtime detector. If you just Google 2019 worst server outages, you'll get a list of, companies that have had problems. Especially nowadays when everything's moving to the cloud and there's software as a service and you're selling your customers subscriptions to product, they want to hear about uptime. They don't want to hear about downtime. So some of these major trends in software engineering is, writing clean code, building configurable infrastructure and libraries, but also starting the journey with monitoring and learning, and that begins with observability. One form of observing your uptime is having a target of high availability. If you Google high availability, you look at this Wikipedia page, and you may have heard about the nines of availability. A lot of business apps target, 3.5, 4 nines of high availability. That means per service level agreement, they can only have 8 hours for 3 nines, or 4 hours, 3.5, or an hour of downtime per year. This is an important goal to go after. That it means that everything's just running well in your servers and your infrastructure. It also means that when you deploy updates to your application, you don't take down your system. And there's still a lot of work in the industry to do that last part with high availability deployments, such that you're replacing components that are hot and that have traffic with new components that start up and then shift the traffic over. Blue-green environments, there's Kubernetes handles a lot of this with their pods. But the name of the game here is uptime, and committing towards uptime because that's a better UX. And the more recognizable your brand is and the more use your system is, obviously the higher the uptime you're going to want. So on the NASDAQ project, we targeted 4 nines of availability, and we need to figure out how to make that happen even in the context of disaster. So that's a whole DR thing. I won't get into that. But keep in mind, the most up-to-date modern teams are really focused on maximizing uptime. So how would you monitor if you were getting into this game? There's some basic low-hanging fruit subscriptions that you can buy, like Pingdom. Pingdom will ping your web app every few seconds and say, are you up, are you up, are you up? Similarly, there are health checks in your services that report to load balancers and say, yeah, okay, I'm up. And if you don't respond, the load balancer can take that server, that host, out of the load balancer and begin to spin up a new one, or just not send traffic to it. But going beyond like simple pings, you could monitor application performance and graph on alert on errors, or look for latency percentages, like 95 or 99% of the requests to the server respond within a certain amount of time, and provide the payload that's requested, limiting any latency there. You could trace requests from end to end across all of your microservices and distributed systems. That's a challenge in of itself. Like, what if you had 50 little different microservices? The customer doesn't know that. They don't see that. But their UX is they onboard, they do stuff, and they go through all your different servers. What if they get stuck in the middle? How do you know which service was the issue? And building on that, you can instrument your code with open source tracing libraries to really see the performance of your app, and there's lots of tooling there. So speaking of tooling, top cloud monitoring and management software tools, you'll see the Datadog picture here on the right, but AWS and Google, they obviously have their own built into the cloud, and there's a bunch of other options here. It's a trade-off analysis, figuring out what the price of these things are, what the value they bring, how easy they are to integrate. Datadog is considered a thought leader. You can see them in the upper right quadrant here in terms of stronger strategy and, up there with Dynatrace and others. So that's kind of why we're talking about them, because of their thought leadership. So if you were to get interested in Datadog or some tool like it, there's going to be an onboarding price and penalty. So let me talk to you about my experience onboarding with Datadog. Getting started is very inviting. They're like, hey, no credit card required, free trial, 14 days. Where do you want your data stored? And oh, by the way, tell us about your stack. It's kind of fun. I'm like, all right, I'm running a node stack and Docker containers in AWS. So it's very inviting. However, for me, the next steps was this agent thing. And intuitively, having used it back in the day, I knew what the agent kind of was. It's about collecting data from my servers and sending it to their servers. But it really wasn't resonating with me in terms of the next steps with their onboarding. I was like, options for install didn't quite fit my use case. I didn't really want to build from source. I wasn't going to config it into the OS itself. I wasn't using Chef or Ansible or other traditional DevOps scripts like in Puppet as well. So I kind of was there scratching my head about the next steps. And what I came up with is like, all right, well, I know Docker. So let me just, run this Docker run command on my Mac and pass in my Datadog key. And that worked. It was like, congrats, your Datadog agent is reporting. And I was like, all right, that's cool, but why the hell am I monitoring my Mac? Like, I want to monitor my AWS servers. Because all along, I'm thinking to myself, I really just want to get into AWS. So it was a little wonky that I had to kind of fake their agent out in order to get it running locally, but then to get to, where I really needed to be, which was AWS. So that's the part that they made super interesting and cool, where it gave me this value prop of, click some buttons and automatically set up CloudWatch metrics and, basically hook into the APIs at AWS and bring that data out and over into Datadog. They made it so easy with this cloud formation stack, such that I could just say, create stack, and it runs this this YAML file you see listed here. It took a while, and it told me it was done, and it didn't actually finish all the things it said it would install. So I was like, all right, well, I guess it's done. It says it's done. So I kind of went on to the next steps and was excited that AWS was now integrated with Datadog. But this is the tip of the iceberg for their integrations offering, and this is a screenshot of their web app. And this is where they get really impressive in terms of being able to add services across the cloud providers. I happened to screen capture some of the AWS services, but they made it really easy to add these integrations in. So bonus points there for me. So let's talk about this agent. This agent is a lightweight piece of software installed on your hosts and containers. It was originally written in Python. I think it's written in Go now, at version 7 of it. It reports metrics and events from your hosts to Datadog via integrations, whether it's Dog Stats D or an API. And with additional setup, you can report on more things. So picture UDP packets coming off of your hosts and then translating the HTTP protocol over TCP, forwarding to their secure servers. Datadog collects about 17 billion data points a day from all the, I have 10 to 20,000 different customers. And it's, aggregating all that information and presenting that to you in dashboards. So, but none of this is possible unless you have an agent installed. Let me talk to you about the agent that I set up for the AWS services next. But first, you may want to know that it starts to collect CPU, disk, Docker-based metrics, file handling, input, output, load, memory, network, etc. Even uptime checks. It's all baked into their agent. I think you can even add custom things to instrument and monitor on, and then they'll start to collect that through their agent to their server. So again, back to my use case, I really wanted to look at, you guys may know I'm a fan of Fargate. I really want to look at, my node servers running in Fargate, to refresh everybody's memory what Elastic Container Service is and what Elastic Container Service with Fargate is. They both start with building Docker images, but back in the day, you'd have to deploy those manually to EC2 servers yourself and deal with auto scaling and provisioning and all that. With Fargate, you build your container, you define your memory and CPU, and you basically press go, and it spins up tasks that live within services, and you're good to go. It's serverless in a way because you don't see those EC2 hosts in your account, but they're there. They're just in Amazon's world. This is where things get really interesting, and in terms of what you can monitor with Fargate, every layer of your deployment, track data in your cluster, it builds a map, You can detect services running automatically. You get real-time insights. You can analyze logs. What I will show you is the last one is creating alerts regarding an ECS cluster and Fargate tasks. For those that remember, and I doubt anybody does, but I gave a talk a few months ago about building a full stack application from scratch, part 3. There was a container definition in that JSON for, in the Terraform config file where it's rendering the container definition. So I figure this is the way to hook into it. And that's what Datadog actually suggested. They came up with this Docker sidecar approach. What's a sidecar? If you have a primary app running in a Docker container as a running image, you could have a local network or have a sidecar Docker image running alongside of it, and they can communicate with one another. And that's what this little bit of JSON on the left is. If you add this task definition, the Datadog agent using the latest image from their Docker container, giving your API key, saying you're running Fargate, voila, you're able to sidecar your application and start to get some feedback. By adding that little bit of JSON to my Terraform task config, I replanned the environment, Terraform plan for staging. I then applied it, and I was super thrilled it just worked. I was like, this is great. The Datadog agent is now running as a sidecar container next to my service, and that was like little lift at all. It was literally that little snippet JSON. And what you get out of that is a reward. You get a dashboard with, average memory, CPU time, bytes in and out. So you can start to see your container and the performance of it at runtime. And oh, by the way, I don't even have a server proper or even a server in my account. This is all just container-based Fargate task management with that one little bit of JSON there. So that's pretty cool. To finalize this talk, let me talk about why Datadog is super useful in terms of the alerting side of the equation. It begins with having clear non-functional requirements and a clear goal of figuring out what you would like to alert for. In this case, I wanted to check for cost overrun and CPU low is very low. And that's where the screenshot at the bottom is your friend, because when you start to write the alerting logic, you can actually see where your servers are at runtime, and you see how it's below 5% CPU utilization, so it's in the red, and the red aligns to an alert where the yellow aligns to a warning. And I feel like the way they've set up their dashboards, and they've had this functionality for years, it just makes it super interesting or easy to visualize the logic you're writing in your alerts and how that applies to your service as it's running today. Because the last thing you want is to be woken up in the middle of the night with an alert for something spammy that you didn't quite test out. So here's how you set an alert. You just set some error thresholds. Less than 5%, you alert. Less than 7, you warn, just in this example. And again, it shows you the conditions of your service in the context of that alerting logic. So that's it. That's kind of what I wanted to do, is give you guys an intro into the concept of observing things and monitoring and alerting for the purposes of having analysis of an understanding what's going on with your servers. Explained a little bit why you would monitor and how you would monitor. And then we talked about onboarding in Datadog as well as their agent, and then gave examples of setting up a monitor and ECS task for Fargate, as well as setting up alerts that feed dashboards and other mechanisms to let me know that bad things are happening and it's happening to the servers. So in a nutshell, monitoring is good for predictable failures. Testing is your best effort. And then perhaps down the road, we can talk about simulation of failures. That's all I had for you guys.